Enter the void.
For decades, we had a story of how the universe began. A neat, orderly timeline stretching from the Big Bang to us. It was a story of gradual creation over 13.8 billion years. But the James Webb Space Telescope, well, it's found some plot holes. It's peering into the cosmic dawn and showing us things that, according to our old story, shouldn't exist so early. The rulebook is getting some serious edits in real time, and what we're finding is forcing us to ask some big questions. The story we thought we knew. To understand why cosmologists are so excited, we first need to remember the story we were all pretty confident about. It goes by the mouthful of a name. The Lambda Cold Dark Matter Model, or Lambda-CDM for short. For decades, it's been the bedrock of our understanding. It all starts 13.8 billion years ago with the Big Bang. The universe erupts into existence, expanding from a point of unimaginable density. For the first few 100,000 years, it's a hot, dense soup of particles. Then, as it expands and cools, it enters the cosmic dark ages. No stars, no galaxies, just a vast dark sea of hydrogen and helium gas. Over the next few 100 million years, gravity starts its slow, patient work. The densest patches of gas begin to clump together, collapsing under their own weight to ignite the very first stars. These stars are the building blocks. They live fast, die young, and in their explosive deaths, they seed the universe with the heavier elements needed for everything else. These stellar nurseries then slowly, over billions of years, merge and grow to form the first small, clumpy, and irregular galaxies. Think of the early universe like a nursery. You expect to find infants, small, a bit disorganized, just starting to figure things out. Our models predicted the first billion years of cosmic history would be filled with these baby galaxies, gradually pulling themselves together. For years, this was the accepted timeline, the established order of the cosmos. And then, we opened our new eyes. The unexpected giants. When the James Webb Space Telescope started sending back its first images, astronomers were looking for those faint, infant galaxies. Instead, they found toddlers doing calculus. The JWST Advanced Deep Extragalactic Survey, or JADES, has peered deeper into time than ever before, observing galaxies as they were when the universe was just a tiny fraction of its current age. And it's finding galaxies that are surprisingly massive and well-structured for their age. For example, a galaxy called JADES GSZ 14-0, seen when the universe was only about 290 million years old, is bafflingly bright and large. It's over 1,600 light-years across, and its brightness seems to be powered by a huge population of young stars. The detection of oxygen in this galaxy suggests that multiple generations of massive stars had already lived and died, a process that was thought to take much longer. To put this in perspective, our standard models of galaxy formation have trouble explaining how so much could happen so fast. While the models don't completely break, they are under serious tension. It's like finding a fully grown oak tree in a greenhouse where you only planted the acorn last week. One early study highlighted 6 candidate galaxies from 500 to 700 million years after the Big Bang that appeared shockingly massive. While follow-up studies have tempered some initial estimates, the tension remains. These early galaxies seem to have formed stars with an efficiency that is much higher than what we see in the universe today. These discoveries are challenging our standard cosmological model, pushing cosmologists to refine their theories of how the first galaxies came to be. The black hole, Enigma. And it's not just the galaxies, it's what's lurking at their hearts. The early universe, it turns out, is also home to black holes that are way too big, way too early. The standard theory for how supermassive black holes grow is a gradual one. It starts with a seed, usually the remnant of a massive star, maybe 100 times the mass of our Sun. Over billions of years, this seed slowly packs on weight by gobbling up gas, dust, and stars, and by merging with other black holes. It's a slow and steady wins-the-race kind of model. But JWST is finding black holes that are seriously challenging this timeline. In the galaxy GN-Z11, which we see just 430 million years after the Big Bang, Webb found evidence of a supermassive black hole around 2 million times the mass of our Sun. It's the most distant active supermassive black hole ever detected. Another, in the galaxy CEERS 1019, clocked in around 9 million solar masses just 570 million years after the Big Bang. There just doesn't seem to be enough time for a small, stellar mass seed to grow that enormous that quickly. The universe was just too young. It's pushing the limits of our models. What's even weirder is that some of these ancient black holes are bizarrely oversized for their host galaxies. In the modern universe, a supermassive black hole is typically a tiny fraction of its galaxy's total mass, about 0.1%. But some of these early black holes appear to make up a much larger percentage of their galaxy's mass. They're giants living in surprisingly small houses. This imbalance suggests that our understanding of how black holes and galaxies grow up together might be incomplete. We are staring at evidence that challenges decades of scientific theory. From galaxies that grew up too fast to black holes that got too big, the James Webb Space Telescope is showing us a universe that's more complex than we ever imagined. What could possibly explain these cosmic puzzles? Before we explore the new ideas on the table, if you're finding this journey to the edge of knowledge as thrilling as I am, take a moment to subscribe and join us for more deep dives into the mysteries of the cosmos. The scramble for answers. This isn't a failure of science. It's the scientific process playing out in glorious real time. Every impossible discovery is a clue, pushing us toward a deeper, more accurate picture of reality. Right now, scientists around the world are in a race to solve this cosmic puzzle, and some of the theories they're exploring are revolutionary. One leading idea tackles the black hole problem head-on. What if the first black hole seeds weren't small at all? A theory known as direct collapse proposes that under the extreme conditions of the primordial universe, massive clouds of pristine gas could have collapsed directly into a black hole, skipping the star phase entirely. This would create heavy seeds, already tens of thousands of times the mass of the Sun, giving them a crucial head start to become the giants JWST is finding. Another possibility involves the very first generation of stars, known as population 3 stars. Composed of only hydrogen and helium, these theoretical giants could have been far more massive than any star that exists today. They would have burned incredibly bright and collapsed into larger than expected black holes, providing bigger seeds for growth. JWST has found tantalizing clues that might point to these pristine stars, like detecting a pocket of unusually pure gas in the halo of the galaxy GN-ZE11-, a potential POP3 star nursery. But some scientists are proposing more fundamental changes. What if the problem isn't just how galaxies and black holes grow, but with our core understanding of the universe? A controversial alternative to dark matter, known as modified Newtonian dynamics, or MOND, suggests gravity behaves differently on cosmic scales. Proponents argue that JWST's observations of well-formed bright early galaxies fit better with MOND's predictions. However, this idea remains contentious, and most of the scientific community still favors the standard Lambda-CDM model, believing it can be modified to fit the new data. What we are witnessing is a major shift in cosmology, happening right before our eyes. The James Webb Space Telescope isn't just an observatory, it's a time machine. And it has taken us back to the dawn of everything, only to reveal that the story of creation is far more complex than we knew. The old simple timeline is being revised. In its place, we're getting a picture of a universe that was surprisingly dynamic and capable from its earliest moments, forming massive galaxies and giant black holes with an efficiency that currently defies our neatest explanations. Are these unexpected objects the result of massive primordial seeds? Do they hint at a new understanding of gravity? Or are they pointing to a truth about our universe that is stranger than any of our current theories? We don't have all the answers yet. But for the first time in a generation, some of the most fundamental questions of cosmology, how did it all begin and how did we get here, are buzzing with new excitement. The textbook is being rewritten. The old story isn't necessarily broken, but a new, more magnificent chapter is just beginning, and the James Webb Space Telescope is helping us write the very first lines. The coming years promise a revolution in our understanding of the cosmos. As Webb continues to stare into the abyss, we'll uncover more clues to this incredible mystery. If you want to stay on the front lines of this scientific adventure, make sure you're subscribed and hit the notification bell. What do you think is the most likely explanation for these surprising discoveries? Let us know in the comments below. Stay curious,